In this video, we'll learn how the Transit Gateway can be used to connect multiple AWS VPCs and also to make other types of connections as well. Okay, so let's start with a simple scenario here. Let's say that we have 5 VPCs. I have labeled them VPC A, B, C, D, and E. And maybe we want all of these VPCs to be able to communicate with each other. Well, let's start with VPC A. Yeah, if I wanted to, rephrase. I could create VPC peering connections from VPC A to all of these other VPCs. And so I'd have to create 4 VPC peering connections and create the necessary entries in my route tables. And then for VPC B, if I want that to be able to communicate with the other VPCs, I'd have to create some more VPC peering connections. And same thing for VPC C and VPC D. And when it's all said and done, I actually end up creating a total of 10 VPC peering connections to allow these 5 VPCs to communicate amongst themselves, along with all of the associated route table entries. So that's a lot to manage. Now imagine this was 20 or 30 VPCs. The problem just grows and grows and grows as you have more VPCs. And in addition to that, let's assume that I have an on-premises data center, a physical data center that I want to connect to as well. And if I want to connect my VPCs to that, I'm going to have to manage connections for each of those VPCs to that on-premises data center. So whether it is a VPN or whether it is direct connect, either way, I'm going to have to manage individual connections for each VPC. So the use case that we're thinking of here, and by the way, if you're preparing for a certification test like the AWS Architect Associate, that's the use case that's covered on the exam, is the fact that we have many VPCs that we want to peer together, but we don't want to manage a bunch of VPC peering connections. If I don't want to manage all of those VPC peering connections, I can just create a single transit gateway and connect all of my VPCs to that. And in doing so, I create a classic hub and spoke topology, where at the center of my diagram, I've got the transit gateway, and all around it, I've got all of these VPCs, and it can connect to all of those VPCs. So now I've enabled communication across all of my VPCs. Oh, and by the way, I can also connect my on-premises data center to a transit gateway. I can terminate either a VPN or direct connect at the transit gateway. So now I've enabled all of my VPCs to communicate with the on-premises data center through the transit gateway. Now, there are additional costs with the transit gateway that we need to be aware of. With the transit gateway, you are going to pay for each of these attachments. So for everything that you're attaching to the transit gateway, every VPC, you are going to pay an hourly cost. You're also going to pay per gigabyte for all of the data that flows through the transit gateway. So typically those costs are about 2 cents per gigabyte of data. But again, that can vary by region and those prices may change over time. But as a rough rule of thumb, it's going to be approximately 2 cents per gigabyte. And those data processing charges apply to traffic that's going from one VPC to another, or a traffic that could be going to the on-premises data center as well. And that's one of the big differences between the transit gateway and VPC peering. VPC peering doesn't come with any hourly charges. VPC peering doesn't come with any attachment fees. The only real cost with VPC peering is if you are transferring data from one region to another or from one availability zone to another, but those costs are always there anyhow. So with VPC peering, you're only paying for the normal data transfer rates. But there is definitely a benefit to having the Transit Gateway, because the Transit Gateway makes my network so much easier to manage, so much easier to understand here. Everything just connects to the Transit Gateway, and from there we can get from any VPC to any other VPC or to our on-premises data center.